Welcome to the TimCo Retail Manager course. This course focuses on real-world application development. In this video, we're going to be addressing how to handle SQL transactions inside CSharp. Specifically, how to use them, when to use them over a transaction inside SQL, and what implicit transactions are. Now, Patreon members, don't forget to head over to get the source code for this video, as long as you're at the $5 per month level or higher. Also, no matter what level you're at, don't miss the tour of my office, my favorite books, and how I create these videos. That's currently posted on Patreon. I hope you find that both enjoyable and informative. Now, as we move forward in this video, I'd love to hear your thoughts. Please let me know what you want to see different or improved in the application. Your feedback is what makes this application even better. So let's get started. Now, I decided to do something a little bit different in this video compared to the previous ones because I think it's an area we haven't really seen yet demonstrated. I want to demonstrate what it looks like when you come into the application and it's not pristine. So if we come over here, we go to Team Explorer, and notice under Changes, I had it already pulled up here. Under Changes, there's actually changes already done. Now, I want to do everything I can on screen, and so this is the first thing I've ever done in this series that's off screen. And it's a small little change, but I want to make sure that I demonstrated what you would do in this case to review these changes. Let's just say that you're working with somebody and they made the change, and now they want you to review it. Now, normally that'd be a commit that you then do a review on, but in this case, we're just going to look at the changes and then we're going to commit it ourselves. So it's like somebody sat down at our computer, did the work, and then said, does that look good? So let's look at what the change is. We have 3 different files that have been changed. Now, this comes from a viewer who pointed out a problem I had in my code, and it's a quick little bug fix, and I want to make sure I got it in place. But let's look at what it is. So we have shell view model, API helper, and IAPI helper. Let's look at API helper. So we're going to right click on it and say compare with unmodified. Because if we just open this, that's great, but what changed? So if we right click and say compare with unmodified, we can see right away here is the one bit of code that's changed. Notice in green. So on the left, we have head. And head this is the source code at the last commit on our computer. So the last commit, that's the source code. On the right is the source code as it is right now. So here's the changes compared to our last commit. So notice, if I scroll up at the top, notice the bar here on the right has this green section. That indicates that something has been added to this file. You would see red if it had been removed. And if there was a change, you would see both red and green. That's how Git looks at changes, is as a removal and then an addition. So let's scroll down here to the green section, which we were just at, and review the code that has been added. In this case, we have one method, log off user, and we have one line in that method, which is default request headers.clear. So what happened was, and here's the bug that was introduced when I introduced the log off method. In the log off method, I was clearing out the first name, the last name, the token, all that information about the logged in user. However, if you notice, and this is something I missed, if you notice right down here we log in the user, we clear the headers, and then we add an authorization header with that token. So by not clearing that back out, what happened was, and let's unpin this to have a little more space. What happened was that token was still in place. So as long as it didn't expire, even though the user's logged off, there is a way to get back and start using that again. Now we have to bypass some of our WPF front end or make some changes there to get them away from the login page and back to the sales page. But it's still not something we want to allow because that's a security hole. So what I did, I created this method inside this API helper called logoffUser, which just clears that header. So that's all it does. If we go back to Team Explorer and look at iAPI helper, we'll see that one addition is to the interface to add the logoffUser method to our interface. And then finally, shell view model. If we look at that, notice I'm double clicking, and that double click is that comparison. So there's a few more changes in here. Notice on the left hand side we have red, and on the right hand side we have green. That's that change I talked about. So let's review these changes. First, we have the addition of this using statement for trm desktop UI.library.api. We then bring in the iAPI helper, and then in our constructor, we ask for that iAPI helper. And we map that over to the private variable underscore API helper. So that's just kind of setup stuff. Let's scroll down to this next green line. In our log out method, we have logoffUser, which what that does, if we go to the logoffUser, we can control F12. And it's not going there. Let's find out where that is. It's probably because it's in this comparison view. So let's do this. Let's open this up in non-comparison view. It's not cooperating here. There we go. And for our logoffUser, control F12 takes us to this method, which has clear the token, clear the ID, first name, last name, email address, and set the create date to the min value. Now that's inside the model itself, and that's just a clear method. Now one thought might be, well, why don't you have the logoff here? So call the API helper inside this model. And the reason why is because the model, I just wanted to worry about the model. I want it to be only properties except for the methods that affect those properties. And that's it. I don't want logic inside a model. Therefore, I'm not going to put it there. I'm going to put it afterwards in this logoffUser right in the logout method. So it's two steps. LogoffUser clears the information about the user, and then logoffUser in the API helper goes ahead and clears out that header. Now, I am thinking that maybe I don't like the word logoffUser, so maybe I change that to something else. I think I'll call this reset user instead. So instead of logoffUser, we're going to say reset user model. So that will clear out this user model. Let's go into the interface, F12, and change from logoffUser to reset user model, control dot, and rename that. And now if you come over here, it says reset user model. Now I just added an additional change, actually two changes, to my list, and now I have 5 things that are changed. So I've reviewed this series of changes, which I should probably complete, but I want to make a change and add something, and now I have done so. So I've reviewed it and said, well, that's close, but not quite all I want to do. So there's the changes now that I've made, as well as the other user has made to add this logoffUser. So now I have all the changes in place for that one little tweak. Let's go ahead and commit this now that I know that these are all valid changes or changes I want to have added. I highlight them all, hit stage, and say fix log off bug. Fixes the bug where the header was not being cleared on log off. And we'll hit commit to staged. Okay, so there's that change, and now we have a clean repository. We go to sync here. We can do a fetch to make sure there's nothing else on the server, and there's not. And we could push this right now. I'll wait to push it until, well, no, you know what? I'm going to push it right now. And then we'll push again once we've made our changes today. So that's just kind of getting started. I just want to demonstrate that, what would happen if you already had changes in place. Maybe you forgot to commit. A good thing to do is to make sure you review those changes before you just accept them blindly or throw them into a commit. Okay, now let's talk about SQL Transactions, because this is a topic that came up in the comments. Again, comments are driving a lot of stuff in this course, and it's great. So this came up in the discussion around our sales data. So in sales data, which we have it to do here to make this better. And so this is actually one of those things that needs to be done to make this better. And that is that down here, we insert the header record for sales data, and then we get the ID back, which that's not the best. We've got to fix that first of all, because it's not returning it as directly in our parameters. And then we separately save the data for this insert. So what that does is it breaks this up into different transactions. And the problem there is, if, let's just say this works. So we insert our sales record and it works, and we get an ID back of 5. And then come through here, we have, let's say, 4 items to insert, and one of them fails. So now we have 3 out of 4 entries for that parent record inserted, but not the 4th. That's kind of a problem. We'd have a half-formed sale in our database, and that's never good. That's corrupt data. We don't want corrupt data going into SQL Server. And one of the things that SQL Server is known for is it passes the ACID test, ACID, and one of those talks about the idea that transactions should be one whole chunk instead of broken into pieces. So, for example, the easy example is moving money from your checking account to your savings account. If you withdraw $100 from your savings account to put into your checking account, if the insert into your checking account fails, you don't want half that transaction to work. Meaning you don't want to have the remove $100 to work if the insert $100 fails. Otherwise, $100 just disappears from your account, and that's not good. Well, in the same way here, we don't want to say we had a sale and say we sold 4 things for, $50 total, and then have just 2 things for our details that add up to $25. That would be confusing, and it's also wrong. There's a problem there. So what we need to do is we need all of these calls to be wrapped into one transaction. What a transaction does is it says either the whole thing works or the whole thing fails. There is no part to this. You can't have a partial working solution. All succeed or all fail. Normally, we do transactions inside SQL. So that we start a transaction, we do 2 or 3 or 4 operations, and then at the end of it, if everything has succeeded, then we commit that transaction, which saves all that data to the database at once. In our case, it's a little bit more tricky, and here's why. There's 2 pieces that we have to think through. First of all is this ID. So we get the insert, and we get an ID back. And again, we have to fix this. I'm not sure if we'll get to it today or not. We are going to fix it so it comes back with the insert. Because that's right now it's not a great solution. But we get the ID back, and then from that, we do multiple inserts for the details using that ID. So if we're going to do one store procedure, we would have to have some way of inserting multiple rows with our store procedure. Now we can do that using a table value parameter, TVP. But that's probably not the best solution because you don't really want to have hundreds of these TVPs around. And so instead, I think what we're going to do, I know what we're going to do, is we're going to do a CSharp SQL transaction, meaning CSharp will handle the opening and closing of the transaction, not SQL. Now, before we do this, I do want to say, and I want you to hear me on this, this is something you use sparingly. Do not always open transactions inside CSharp. Most of the time, you don't need to do that. And in fact, it can be very, very dangerous because you do not want to have an open transaction from your SQL code. I'm sorry, from your C# code. So if you open the transaction and forget to close it, that's a big deal. Don't do that. That can cause some serious performance degradation on your SQL server. So we're going to have to make sure we're very careful how we do this. But in this case, it makes sense. Now, the other thing that was pointed out that is a little tweak that I want to make sure I do is in our store procedure for sale insert, we grabbed identity when that should be scope identity. And that's actually with the OpenClosed Parens. Whoops. There we go. So what that'll do is it will get the identity for the given scope, in this case, this store procedure. So we haven't used this yet, so it wasn't a problem for us. But with just identity, what that does, it gets the last inserted identity value, or last created identity value. The problem is if you have multiple different applications all inserting data, then you might get an ID for something totally different. So you want the scope identity, which the scope is this procedure. So that's just something else to note. Okay, so that was one little tweak we need to make sure we do. Even though we're not using this yet, we need to make sure that that scope is correct. Okay, now let's look at how to apply a transaction to this code. Now, right now, you can see SQL.save, SQL.load, SQL.save. They're all separate. Now, they all call the SQL data access. So if we hit F12 here, we can see that in SQL data access, we have load data and save data, and it opens a connection and then immediately closes it once it's done. This is ideal because we never leave a connection open for very long, which is another performance hit on your SQL server. Always close down your connections by default as quickly as possible. But in our case, we have to open a connection, start a transaction, do multiple calls, and then close the connection. So we can't use the load data or save data method we have here. We need something different. So let's map out what we need. We need to have a open connection / start transaction method. We need to have a load using the transaction. We need to have a save using the transaction. And we need to have a close connection slash stop transaction. Not in that order. Method. I think another thing we need is we need to implement dispose. That way we can wrap this whole thing in a using statement and make sure that we close that connection, stop the transaction, do all that cleanup code no matter what. So let's make sure we do that as well. So let's start with our open the connection and start the transaction. So public void start transaction. Now, yes, it's doing more than starting a transaction. It's also opening a connection, but I think that gets us where we need to go. Let's also pass in that connection string name. So with this, we're going to do two things. One, we're going to create this connection right here. And then two, we're going to create a transaction. So let's create two private variables. The first one is an IDB connection. Call it connection. Let's call it underscore connection. Because we're using connection up here inside of our methods. So I don't want to use that same name. So this connection, and we're not going to instantiate it. We're going to leave it like so. And then we'll do another one that, private IDB transaction. Call it transaction. And now inside here, we can't do this using statement because that using statement closes at the end of the curly brace. So we're going to do something a little bit different, and that is we're going to say, let's take this code right here and say underscore connection equals, got two equals there. There we go. Connection string, and it's actually connection string name. We need to get the connection string like so. There we go. So we're getting the connection string, then we connect to our SQL server and open that connection up. And then after that, we're going to say transaction equals connection dot begin transaction. So that starts off the connection. Now, let's create another method that is public void stop transaction. Don't need to pass anything in. And this is a little bit interesting because we may call this method more than once. So let's start off with the transaction. Transaction dot question mark dot, in case it's null, commit. Now, why would I commit this if I don't know if it succeeded or not? Well, if we call the stop transaction, that means it has succeeded. We can create a different one to fail the transaction, or we can do is say don't call the stop transaction unless it has succeeded, and then have the dispose fail the transaction. So there's a couple ways you can go about this. I think we'll create two methods here, one called stop transaction successfully, and maybe one called fail transaction. So let's do that. Actually, you know what? Nope. Let's call it just what it's called. Commit transaction. Commit transaction. It'll create another one right now. Public void rollback transaction. And we'll have underscore transaction question mark dot rollback. And what rollback does, just what it sounds like, it erases all the changes we've made instead of committing them. So a commit applies that to the database. The rollback deletes everything we've done. Now we'll have a connection question mark dot close. And that will close out the connection. We'll do that either way. Now the question marks are null checks. So if this object is null, then it won't do this work. But that way, we can call this multiple times. If it is null, it just we'll skip that line. Therefore, we can call it multiple times. Now with all of that done, we have our start transaction, and we have our two different ways to end the transaction. I want to, at this point, implement the IDisposable. So at the top here, on our SQL Data Access, our class, I'm going to say IDisposable. And this is something that Microsoft provides, and it's an interface. And if we control dot to implement this interface, it adds just one method. And that's right down here now. That method's called dispose. And what happens is that when you're at the end of a using statement, so up here we have a using statement. At the end of this, so right here, even if we have not closed this connection, it will run that dispose method. So it will do something to clean up this method. So let's say that the dispose method is going to commit the transaction. Because just like up here, I don't call the connection close explicitly, I call it implicitly. So we're assuming that it succeeded. Therefore, we're going to call the commit transaction in the dispose. Now, if I do it explicitly as well, that's no problem. We can call this more than once. But this way, we're sure the transaction gets closed and the connection gets closed. Now, one question you may have is the connection itself. If we look here, it also has a dispose method. Now, which do you call, close or dispose? The reality is they're the same, exactly the same. So which one you choose, I choose close. That makes the most sense to me. Essentially, they're doing what we're doing. We have this dispose method, and inside of it, we're calling the commit, which closes things out. The same thing is true for the connection. It has a dispose method because it implements IDisposable. And what it does is it calls its own close method inside that dispose method. So we're doing the same thing Microsoft is doing. Now that we have these, we have a start transaction, we have the commit or rollback transaction, we have our dispose. Now we can look at how to do these two right here, which are load data and save data. So let's start with save data. I'm going to copy this, and I'm going to paste it right here. Now, right now we have, let's call save data in transaction. And we don't need to pass in a connection string because we've already done that since we've opened the connection already. We don't need to get the connection string name. We don't need to have this using statement. We really just need to have underscore connection dot execute, pass this information in, but don't forget at the end of this, say transaction : underscore transaction. Pass that transaction in. Otherwise, it won't use that transaction for this call. So we'll make sure we associate the transaction with the call, saying this call is part of the overall transaction we're running. So that's a save. We can do the same thing with load. Let's copy this. We'll come down here, paste it in transaction, and we can delete out our connection string name. We can delete the get in the connection string. We can delete this line and this line and this line. And then say underscore connection. But again, make sure that you pass in transaction colon underscore transaction. Now, why transaction colon? Well, I am passing in parameters that might not be in the order that they're asking for them. We have quite a few default parameters. But if I do the Control Shift space, actually it's off the screen, that's excellent. Control Shift space, I'm using a larger screen, so it's actually off to the left of this on my screen. You can't see it. But what it brings up is a number of different options for parameters I can pass in, and they all have defaults. So I can pick and choose which parameters I want to pass in by saying the parameter name colon and the value. So in this case, I want to add transaction colon. I want to pass in a transaction, and there's the value. So with that done, I now have a load data in transaction and a save data in transaction. Now I can start to use this. So back over here, we have our creation of our SQL Data Access class, but now what we can do is add a using statement where we say using and bring in this call right here. So using this call, and now all the calls inside here will be made together, but then at the end, we're going to destroy the SQL object and call that dispose method, whether we do it explicitly as well or not. Now I can move these calls inside. But first, we want to say SQL dot, and we have a start transaction on TRM data. Then we pass in just two parameters for save data in transaction. And then we can do, let's move this comment down as well. We can move these in as well. So let's cut these out from down there and paste them in. We can say load data in transaction. Then make sure that we don't pass in TRM data. We don't need it. And then down here, we don't pass in TRM data, but we do change this to say in transaction. So now all of this will happen inside a transaction. At the end of this, we can say SQL.commit transaction to do it explicitly, or we can leave it alone because the using statement will take care of it. Let's leave it alone for now, but first I'm going to cut this entire thing out and I'm going to wrap it in a try-catch. So let's actually not cut it. Let's just right-click and say snippet, surround with try, and hit tab. And we'll capture, let's not capture the exception. I don't want to pretend like we're going to use the exception. We're not. Here we're going to say SQL.rollback transaction. So if anything happens, roll back that transaction. Now, we do need to tell the user in some way. Right now we're not, and right now I think what I'm going to do is do this. Do a throw. So I'm going to roll that transaction back and then throw that exception so that the next thing up the food chain will catch it. Now don't catch EX and then throw EX. Just say throw. That'll throw the original exception. Now with this, I have a start transaction and then the catch rolls back the transaction. I think I am going to do the SQL.commit transaction statement. I know we're going to do it again right down here, but visually, seeing the start transaction and commit transaction is just, it's satisfying and it makes sense. Okay, I can see the start and I can see the end. I'm not as big a fan of the implicit end when we have an explicit start, because then it looks like we only have a start and a roll back, and you don't see the commit. This way, if you get to this line with no exceptions, then you're fine to commit. Therefore, go ahead and commit. Now let's make sure that this works. That's always an important step in any application, is making sure that the application runs. So it's starting up, and as soon as my API loads, so it's on the other screen, but once it loads, then I hit log in. And now I can say add a skillet, add a home repair kit, and check out. And it looks like something happened. Let's put a commit down here, or a breakpoint, I'm sorry, on our commit and hit check out. And it looks like that didn't happen after all. So let's find out why. Let's put a breakpoint up here and hit check out. We're going to step over the, right away, start transaction. And we get an exception. So let's do this. Let's do exception, EX. And right now we're not using it, but if we put our breakpoint inside, then what will happen is we'll be able to read that exception. We're going to log in. We're going to add a couple of items to the cart and hit checkout. We have this rollback, and so we look at the locals window and we look at EX and we look at the message, invalid operation, the connection is closed. Okay. So we can fix that. Come down here to our start connection, and after we open the connection, we're going to say connection.open. And then in our connection, we already have closed, so we're good to go. Makes sense if we if we close it, we have to first open it. Let's try it again. So that little exception EX is handy for debugging. The fact that I don't want to have it there, though, for much longer. Once it works, I'll take it back out, because if we're not going to create a variable not to use it. So we have no rollback. So let's go over here and make sure that, in fact, we have a commit, and we do. So we're committing our data, and it's not clearing this out. It should. We'll have to work on making sure that's wired up. But it is at least committing our transaction. Let's make sure it's in the database. That's the next thing to verify. So I believe it's in local DB databases. I have a few of these, but TRM data, tables, and we have our sale. Let's view data. and we have a sale on 8/5 at 3 in the morning. It's not really 3 in the morning here. Don't think that I'm a martyr and staying up till almost 4 in the morning. In fact, this is UTC time, and I am UTC -5. It's only almost midnight. Actually, it's -4 right now because of daylight savings time. So it's hard to keep track of sometimes. But we do have our sale data, and if we looked here, we should have our sale detail data as well. And in fact, we do. That's this data right here, and then again right there. So that transaction worked, and we had the rollback, so that worked as well because when we had that exception, it immediately triggered the rollback. Now, we hadn't made any calls yet, but that way we're sure that things are working correctly. With that being done, we can clear out this variable we're not using except for debugging. And, we can clear out the parens as well. We should clear out the parens as well. And we can make a commit. So we can grab. This actually is a separate change. So this change right here, we change a scope identity. Therefore, I'm going to make this a separate commit. So I'm going to stage just that. And I'm going to say fix identity lookup used scope identity now. I'll commit that. And now I'll commit the rest of my changes because these are a separate chunk of change. And this is add transactions, add transactions to SQL data access and used them for the sales data call. We hit commit staged, and now we can go to our sync, and now we have 2 commits to push. No, remember we pushed the one previous already, so we could do a fetch just in case somebody else has changed anything, but again, just me working the project, so now I can push those 2 commits. So with that done, we have now added transaction ability to our data access. So we can either do the load data and save data the quick way, or we can do the longer route of start a transaction, load or save the data, and then commit or roll back that transaction. In general, we don't want to use this second method. We don't want to use the transactions inside CSharp. Because if anything happens and we don't do it just right, we might leave a transaction open. And open transactions are not good. We definitely want to close those out. So be very careful using this code. But there are times when it's useful. And I thought that this was a good example of a time when it's useful. Now, you may have the question about the load data in a transaction, because loading data isn't necessarily something that makes breaking changes. So just reading your checking account balance doesn't need to be part of a transaction. However, in our case, and in other cases as well, if you need to read data that you have modified in a transaction, you need to make sure you read that data inside the transaction, because it's not in the database yet. It appears to be if you're inside a transaction, but it's not if you're outside of that transaction. That's why we have this load in transaction method. If you just want to do a one-off read the database for committed work, then use the method up here, load data. But if you're reading data where you've already started a transaction and done some work, then load data in transaction is what you'd use. Now, the contrasting way that we could have done this is if we wanted to allow SQL to do the transaction, and that's typically the preferred method of going about it. Again, I think this situation is the exception to the rule. But if you decided I want to do this in SQL, what I would have done is modified this sale insert to accept that table value parameter, which is basically a table. And that would basically be all of these values would be one row. And we have the ability to have multiple rows. So with that, I would do the insert. I would first start, I do a begin trans here. I would do the insert. I would do my select. I would then do multiple inserts using that table value parameter and this ID. The cool thing is I wouldn't have to do a loop. I could just use the SQL version of that, which, let's just modify that and undo it. It would be, insert into, let's actually look at what it'd be, this right here. So it would be this right here, but instead of values, what it would be is select, let's just say star, from our, table value parameter. Now we also have in here, at ID, comma, and then all the different values. So it probably look more like this. So that's what it looked like. So that is pretty simple to read. And we have our commit at the end. And then we'd have this wrapped in a try catch inside SQL. And then we'd have a rollback on any error. So that's how you do it if you want to do it inside of SQL. But again, that table value parameter, I try not to create tons of those. I try and limit those to important large-scale inserts. I try not to have it for, okay, we're going to enter 2 to 5 records. I try not to go there because it seems like it's a lot of overhead to maintain, and it's a lot of stuff to keep track of inside of your SQL server. So that's how I would have done it in SQL. Okay, let's undo those changes. So I undo, and it says, are you sure? Yes, I'm sure. They go away, and now this is that head version, the version that is the last commit in Git on my local machine. So that's it for SQL Transactions, both on SQL Server as well as how we did it, which is inside CSharp. You can definitely use this code for other circumstances where you need transactions. Just like I said, make sure that you are careful how much you use it. Now, if you have questions on how to do this, definitely leave a question down in the comment below. Or if you saw something where you said, hey, Tim, I think you missed this, or this would make that better. I love to hear about it. This video has about 3 different changes that were suggested by users that were watching this video. So thank you for that. I appreciate it. I appreciate that you point out these issues, and it's great that I'm doing this along with you because I get a chance to make these changes right away. If I had scripted all this out, I'd have to come back and explain it later, and that's kind of hard. So thank you for watching that and making sure that you identify those issues. All right, for what's coming up next, we still have dependency injection to handle in our API, and we need to add that MVC project. The MVC project will probably be a lot of this manipulation or viewing of user information and adding product information, adding inventory, those type of things. So I think that's what I'm going to do with that. It's going to be more of a managerial side of things. So we'll have some limitations on who can access that, not just every user who's authenticated. So that'll be interesting, and that's coming up soon. We also need to modify our store procedures so that we don't have to return or do that select statement. And I also want to make sure that we're updating our inventory. So right now our inventory is not changing. So we look at our inventory here. Oops, not inventory. It's our product list. There we go. So the product list we kind of dummied up. We just kind of threw in some information in here. But what this is going to be is when you add something to the inventory, it adds to our quantity already in stock. And if you buy something like we've been doing, it's going to remove or delete some quantity over here. So we're not doing that yet. I want to add that in, and that'll be part of that transaction. Now we'll do that inside of a store procedure. So the sale detail insert, this right here, when we insert it in a sale detail, we'll also remove that quantity from the product table. So we're going to do that at some point soon as well. I think once those things are done, there's a couple of tweaks in SQL, and then the MVC site and the dependency injection, then we're ready to move on to .NET Core. So we're making some good progress. It's taking some time just because this is an every other week course, but I definitely think we'll make some good progress in the next month or two. So looking forward to it. I hope you are as well. Thanks for watching, and as always, I am Tim Corey.